we'll have markings with these red arrows to show us which sides are the parallel sides. And in this case, as I'm looking here, I've got my top base and my bottom base are the two sides that are going to be your parallel sides. But in isosceles trapezoids, these are very special trapezoids. The base angles are going to be congruent. So that means that the angles that are consecutive, that are along the same base, are going to be congruent to each other. So right here, 77 and 1, since they are consecutive and they're both along the same base going across here, those are going to be congruent. So as I'm starting to find out my angles, angle 1 is going to be 77 degrees. It's going to be the exact same. Now the top two angles, those are going to have a little bit different relationship. They're not going to be congruent, and hopefully you can see that because those top angles 2 and 3, those are no longer acute. Those are now obtuse. But this goes back to chapter 3. Whenever you have parallel lines, so this is parallel to this, and then a transversal cutting through, these two angles are on the same side of the transversal. So we talked about same side interior angles back when we were investigating back in chapter 3. And same side interior angles, those are going to add up to 180. So both 2 and 3 are going to be the same. So once I find one of them, I'll know the other because they're base angles. And in isosceles trapezoids, the base angles are going to be congruent. But all I'm looking for is 3 and 77, since they're same side interior, they are going to add up to 180, which is going to mean that they have to be 103. So 103 plus 77, that's going to add up to 180. So looking at example 2, you can go ahead and try that one on your own. We're going to head down to number 3 here in a second. But you can use the properties of isosceles trapezoids. The base angles are going to be congruent, but then also pulling back some information from section chapter 3, where those same side interior angles are going to add up to 180. And that's also very similar to how our parallelograms worked when we started looking at those. So are there any questions, thoughts, comments, anything that you want clarified from that number 1? And I just thought of something. I was talking about this in my last hour. Where am I looking here? If you're having trouble seeing my screen, up at the top where there's that like little grid on Google Meet, if you shut off grid view, it will make my screen bigger. So I can stay around, help you with that. But if you're having trouble seeing my screen, you can, and it's that grid up top. If you click that, that'll shut off grid view, and that'll make it a little easier to see my screen. I try to zoom it in as much as I can, but if you're still having trouble, if you disable grid view, you can see my screen. I can help you with that after too if you need some help. All right, secondly, we are going to take a look at the mid-segment of a trapezoid. So in a trapezoid, if you find midpoints of the non-parallel sides, so the two sides that are not parallel would be there and there, and then you find that midpoint and connect it, that mid-segment is going to be the average of your two bases. Now we got to talk about what does average mean. Average is actually a statistics measurement, but it can be used in geometric figures too. If we have like this middle segment, it's going to just average out to be like the middle of those two bases. To find the average of 2 of something, what you would do is you would add up those two numbers, and then you would divide by 2 to figure out what that average would be. And that's actually very similar to what we're going to do, or what happens with your semester grade is you're going to average out your first quarter, second quarter. So you'd add up your 2 percentages. Once you add up those 2 percentages, divide by 2, and then that's going to be your average of the quarter. What also happens is that your mid-segment, so right here, this is my mid-segment I'm focusing on. If I double it, which means if I would times it by 2, If I double it, that's also going to equal the sum of my two bases. So if I would multiply that mid-segment by 2, that's also going to equal the sum of my two bases. Now, why would you want to do it that way? Well, what you could do is when you double the mid-segment, you kind of avoid fractions. So when you're doing an average, you're going to use dividing by 2, but I can also work the other way. I can think of doubling, and then you're going to start to avoid fractions. I'm going to show you both ways to set it up, and then you can kind of decide how you would like to do that. So first, using the average. So this mid-segment down here, the mid-segment is going to be the average of your two bases added together. So what that means is my two bases, which are 4 and then 7x plus 4, those two bases, 4 plus 7x plus 4, those two bases divided by 2 are going to equal 3x plus 5. So the average of the sum of my bases is going to equal my mid-segment exactly. So that is one way that I could set it up. And in your notes, you also talked about timesing it by 1/2, and that's doing the same thing as dividing by 2. But if I wanted to solve it that way, I could set up an algebra equation like so. Now over here, I'm not doing this problem, but over here I could set this up. I could take my two bases, 4 plus 7x plus 4. So the two bases, the sum of the two bases could equal the mid-segment doubled. So now instead of dividing the bases by 2, I'm just now doubling the mid-segment, and that's going to make an equivalent equation to get all of my things in my trapezoid to line up. So you have two ways that you could set up these problems. You can either think of it as I'm going to double the mid-segment and equal it to my two bases, or I could find the average of my two bases and then set it equal to the mid-segment. Either way, though, we're going to get the same result. The only thing is when I solve my algebra in this manner, I'm going to have 4 plus 4 is 8. So I end up getting 7x plus 8, which when I divide 7x divided by 2, it's going to give me 3.5x. Divide 8 by 2, 3.5x plus 4 is going to equal 3x plus 5. So you will see you'll get some fractions and things when you do divide by 2. So if you're not a fan of fractions or decimals, then you can still use this other method as well. So it's kind of your preference on how you would like to do that. Let's see. Mason, yes. So multiply what by 2? Correct. So what you could do is once you have it set up like this, I think what you're talking about, Mason, is then you could multiply this side of your equation by 2 to cancel that. And then you'd multiply this side by 2, which is still going to get us back to what we're doing over on this side. Is that kind of what you're thinking? Yeah. So that's why you can do that step. That's fine if you want to do it that way. Or I just went straight to the algebra over on the right there. Whoops, I'm on the wrong one there. But yeah, that's an excellent point. Thank you. All right, so continuing to solve this one, I'm not gonna show every step, but I would subtract 4 over to the 5 to make 1, and then I would subtract 3 over. So I'd end up getting 0.5x is equal to 1, which is gonna make x equal to 2. I just want to show you the algebra over here. You're still going to get 2 on this side. So we're going to get 7x plus 8 is going to equal 6x plus 10. And all I did is distributive property there. Then I'll go ahead and I'll get my x's collected. Subtract 6x over, subtract 8 over. We're still going to get x equals 2. So either way, it's always going to be in that 2-to-1 ratio. The bases are going to add up to the mid-segment doubled, or we can take the bases and divide the bases by 2 and then set them equal to your mid-segment. So I'm going to leave number 4 for you to practice, and you can decide either method, whichever you want to try out there. And then go ahead and check that on the answer key, or you can check with me after this first part of class here. But we're going to continue now to look at kites. Now, I started out with class talking about kites are very similar to rhombuses. When you connect the diagonals on the kites, you're going to start to form triangles. And then the diagonals are going to meet at a special angle. The diagonals are going to meet at a 90 degree. So like when I'm looking at angle 1 here, angle 1 is going to be 90 degrees. Then also that's going to mean I'm dealing with some right triangles. And if I know in a right triangle, if I know that I have a 90-degree angle in a right triangle, that means the other two angles are also going to have to add up to 90, because every time in a triangle, you're going to have 180 total degrees. So in this first diagram, I've got angle 1 is going to be 90, because those where those diagonals meet. And then if I know this angle up here is 45, that means angle 2 is also going to have to be 45, because those two angles need to add up to 90 as well, because 90 and 90 are going to eventually have to get to 180. Now, the last thing about kites is that the kites are going to form congruent triangles, and they're going to be congruent by the HL theorem. So this triangle right here has a hypotenuse the same as this triangle, and then it's also got a leg, this reflexive side, it's got a leg that's congruent over there, and it's going to be congruent to this triangle. So these two triangles are exactly congruent. So what that tells me then is if those two triangles, are exactly congruent, then every angle between the two triangles are also going to be congruent. So that means that angle 3 is also going to be 45. So in a kite, you see a lot of symmetry. You're going to see that the diagonals are going to meet at 90 degrees. And then the second piece of that is that your triangles are going to form congruent parts as well. So we're going to see those couple of things that are happening with these kites. And again, it's just continuing to bring in pieces that we've talked about in the past. So just one last thing here. If you have a triangle right here, this triangle is exactly congruent to this triangle down here. So any angle that you can find in that top triangle, all those congruent pieces in that lower triangle are also going to be congruent as well. So you can use that as you start to find those different angle measures. All right, so we are getting to the end of class. We went a little over today, so thanks for your patience. Just wanted to make sure that we hit each topic that you're going to see in section 6.6. But you are, if you are ready to work on your own, you are free to go. But I will stick around and answer any questions if you need any clarification on anything that we've talked about today. But if you're heading out, have a great day, and we'll see you tomorrow.